So to start off this video, what we're going to do is we're going to start off with our first example, the square root of x plus 1 equals 3. Now, to undo the radical, you just simply square both sides. So, square root of x plus 1 squared equals 3 squared. And so you get x plus 1 equals 9. So the solution is x equals 8. And to verify this is correct, you just sub it back into the original problem. So you have 8 plus 1 equal to 3. And let's see. Oh, well, look at that. The square root of 9 is equal to 3. So this is a solution. So that's how we solve the first problem. All right, so now let's do another problem. Let's say we have 2x plus 9 plus 3 equals 10. All right, so the first thing we have to do is we need to subtract 3 from both sides to isolate the radical. And so we're left with 2x plus 9 equal to 7. And so now, to get all this stuff under the radical, out of the radical, what we do is we need to square both sides. And so we get 2x plus 9, and that is equal to 49. And so now what we do is we just subtract both sides by 9, and we get 2x equals 40. And so now we just divide both sides by 2, and we get our solution of x equals 20. And so now what we can do is we can just sub this back into the equation and verify we actually have a solution. So let's see. So the square root of 2 times 20 plus 9 plus 3 equals 10. So let's see. So we have the square root of 49 plus 3 equaling 10. And we can see that the square root of 49 is 7. So square root of 49 plus 3 is equal to 10. So we do know that x equals 20 is a real solution. All right. So now that we have the basics, let's move on to some harder examples. All right. So now for our next example, we're going to get a little bit harder. So let's just say we have the cube root of x plus 2 plus 9 equal to 13. All right, so now what we need to do is we need to first subtract 9 from both sides to isolate the radical. So now we have the cube root of x plus 2 equal to 4. So now what we need to do is we need to cube root both sides. And so we get x plus 2 equals 64. So now what we got to do is we got to subtract 2 from both sides. We now know one potential solution. X equals 62. And so now to check this, we just need to plug this in. And so we find that, oh look, the cube root of 62 plus 2 plus 9 is indeed equal to 13, because 62 plus 2 is 64. The cube root of 64 is 4, so 4 plus 9 equals 13, and so 13 equals 13. So we have a solution. X is equal to 62. All right, so now for our next example, we're going to do a problem that looks like this. So we have the square root of x minus 30 equal to 6 minus the square root of x. Now you look at this and you're like, uh-oh, what do we do? We have radicals on both sides, and we need to get the x's out from underneath the radical. So the thing we do is we try to eliminate them one at a time by isolating them. And since we already have one isolated over here, what we can do is we can just square both sides. Like that. So now we have x minus 30 equal to 6 minus x root x times 6 minus root x. So now what you got to do is you got to expand this, and so you get 36 minus 6 root x minus 6 root x equal to x, because negative square root of x times negative square root of x is positive x, and that's equal to x minus 30. And so now what we can do is we can subtract both sides by x, and right there you can see how they cancel out. And so now what you want to do is you want to subtract both sides by negative 36. And so now what we have is we have negative 66 equal to, and then we can just add these two together, negative 12 root x. So then we can divide both sides by negative 12. And so what we get is, well, let's see, so 66 divided by 6 is 11. So we can simplify this to 11 halves equals the square root of x. And so now we can just square both sides. And we get x is equal to 121 over 4. Now, we're going to need to check this. So we're going to plug this back into the equation. So let's see. 121 over 4 minus 30 equals 6 minus 121 over 4. And so I'm going to punch this into my calculator, and I'm going to see if this is equal. So 121 over 4 minus 30 equals 6 minus 121 over 4. And that's underneath the radical. And if you look at the calculator, it says this is true. So this is a real solution. So now what I want to do is I want to solve the problem x plus 3 equals x minus 6. So the first thing we got to do is we got to get this out from under the radical. So we need to square both sides. And so now we have x plus 3 equal to x squared minus 6x minus 6x plus 36. And you can kind of see, I'm just going to do it over here real quick. X minus 6, x minus 6. And you can see now how you can get x squared minus 6x plus 36. All right, so now we have x plus 3 equal to x squared minus 12x plus 36. Subtract 3 from both sides. Subtract x from both sides. And we have x squared minus 13x plus 33. And so that is now equal to 0 because that cancels that out. And so now we got to use the quadratic formula to solve this. So negative b over 2a, so we got negative 13 over 2 and then times 1 plus or minus the square root of b squared minus 4ac, so over 2a. So let's just simplify this down a little bit. So 13 halves plus or minus negative 13 squared minus 4ac. And what you get is x equals 13 over 2 plus or minus 13 squared minus 4 times 1 times 33. And that gets you the square root of 37 over 2. And so now you have two solutions. X equals 13 over 2 plus 37 over 2, and x equals 13 over 2 minus the square root of 37 over 2. All right? And so now what you have to do is you have to plug this in to the equation and see if you get a nice result. And so I already checked this. This is a lot of work just to plug it in algebraically. If you just plug it into your calculator, what you'll find is that this value right here is not a real solution, and this value right here is a real solution. So yeah, so your only solution to this problem is x equals 13 over 2 plus root 37 over 2. And so I would highly encourage you to plug this into your calculator to verify that it is indeed true. But basically you're just subbing this back in for x. And just see that it doesn't work. Alright, so our final problem of this video is the square root of negative 4x minus 8 minus 2 equals x. So now the first thing we have to do is we have to get the radical by itself. So we need to add 2 to both sides. So we get the square root of negative 4x minus 8 equal to x plus 2. So now what we have to do is we want to get rid of the radicals, so we square both sides. And what we get is negative 4x minus 8 equals x plus 2 times x plus 2. And so if we expand this out, we get 4x minus 8 equal to x squared plus 2x plus 2x plus 4, which then simplifies down to x squared plus 4x plus 4 equal to negative 4x minus 8. And now what we want to do is we just want to try to combine like terms. So what we're going to do is we're going to add 8 to both sides, and we're going to add 4x to both sides. And what we're going to get is 0 equals x squared plus 8x plus 12. And this factors easily into x plus 6 and x plus 2. So now what we got to do is we just got to test our two solutions that we get, which is x is equivalent to negative 6 and x is equivalent to negative 2. So for x equals negative 6, let's plug this in. So we have negative 4 times negative 6 minus 8 minus 2 equals negative 6. So let's see. So we have square root of 24, because negative 4 times negative 6 minus 8 minus 2 equals negative 6. So we have square root of 16 minus 2 equal to negative 6. And that's wrong because 4 minus 2 does not equal negative 6. So x equals negative 6 is not an actual solution. Let's try x equals negative 2. So let's see here. We have negative 4 times negative 2 minus 8 equal, minus 2 equal to negative 2. And so now what we have is square root of 8 minus 8, and then we have minus 2 equals negative 2. And so since this goes to 0, negative 2 equals negative 2. So x is equal to negative 2, and that's our solution right there. So hopefully that makes radical equations a bit easier for you. And if you have any questions, feel free to leave a comment below. So thank you for watching today, and hope it helps.